Alright, what's up, Algebra 1? Today we are doing 5.6, which is parallel and perpendicular lines. These are actually kind of cool, I think. We talk a lot about slope and how to tell if lines are parallel or perpendicular. So, yeah, like I said, I think it's a pretty cool section. So we'll go ahead and get started. So really quickly, just to refresh your memory on the definition of parallel lines. Parallel lines are lines that are in the same plane that are never going to intersect. All right, so one example of that is down here at this graph. These are parallel lines. And then you can see also the thing that makes lines parallel, and this is kind of the cool part, I think, is that if they have the same slope, they're going to be parallel. All right, so you can see if you were to find the slope-intercept form of each of these lines on this graph, you're going to notice they've both got a slope of 1/2. All right, so since they have the same slope, they're going to be parallel. All right, now if they had the same y-intercept, obviously they'd be the same line. So it's important to note that they've also got different y-intercepts. All right, so I'm going to write that out right here for you. All right, so like I said, two lines are parallel if they have the same slope, and also if they have different y-intercepts. Okay, so I think that's pretty simple, kind of cool. Makes it really easy to tell if lines are parallel or not. Okay, so moving on, this is on page 331. Yep, just had to double check there. Yeah, so we're at problem 1 at the top of page 331, and this is writing an equation of a parallel line. All right, so it says a line passes through the point 12,5 and is parallel to the graph of y equals 2/3 x minus 1. What equation represents the line in slope-intercept form? All right, so step 1 is to identify the slope of the given line, which we can see is 2/3. All right, and then so we know that our parallel line has to have the same slope. All right, so then for step 2, we can write an equation. All right, so because we're given a point 12,5 right here, we know, and I'm just going to copy that down because otherwise I'm going to forget what that point was. We know in order to get something parallel to y equals 2/3 x minus 1, obviously it's got to have the same slope. But we now have the slope and we also have a point. What equation can we write that has a point and a slope? That's right, you're a genius. It's point-slope form. This feels like a Dora episode, right? Yeah, so anyway, so we have y minus y1, which is 5, equals m, which is 2/3, times x minus x1, which is 12. And there's our equation in point-slope form. In case you forgot point-slope form, I know we had it really recently, but just in case, I am going to recopy that down right here. So it's y minus y1 equals m times x minus x1. All right, and then we just took all of this and we plugged it in to our new equation. Okay, so now all we need to do is simplify this and get it into slope-intercept form. All right, so basically that just means isolate the variable y. So we have 2/3 x and then minus 8 when we distribute the 2/3. And we can add 5 to both sides and we will get y equals 2/3 x minus 3. And that should be our final equation for a line that's parallel to this line and also passes through the point 12,5. All right, so on your own, on page 331, I want you to go ahead and try out Got It Problem 1. And once you do that, we're going to go ahead and we're going to move on to perpendicular lines. So give that one a try. All right, so with perpendicular lines, it's kind of similar to parallel because we use the slope to determine if lines are perpendicular. And just as a refresher, perpendicular lines are lines that intersect to form right angles. Okay, so all four angles at their intersection are going to be right angles. All right, again, we do use the slope to tell if lines are perpendicular or not. However, this time we're looking for opposite reciprocals. Okay, so an opposite reciprocal is those are two numbers whose product is -1. All right, so, and I'm going to actually write that over here for you as well. All right, so yeah, perpendicular lines are perpendicular if they have opposite reciprocals, which means their slopes multiply to get -1. All right, it may sound a little bit difficult, but it's really not. Once we get into it, you can definitely handle this. All right, so for example, the example they give is if we have a slope of -3/4. All right, the perpendicular line is going to be where these are flipped. Okay, so we have 4/3, and then it's the opposite sign. All right, so we won't have the negative, so it'll just be +4/3. All right, if you were to multiply these two together, -3/4 times 4/3, you're going to end up with -1. All right, so moving on, we're looking at problem 2, and it's asking, are the graphs of 4y equals -5x plus 12 and y equals 4/5 x minus 8 parallel, perpendicular, or neither? All right, so the main thing we need to do is find the slope of both of them. All right, so for y equals 4/5 x minus 8, we already know the slope, right? Because it tells us right there. So m equals 4/5. On the other one, though, we have 4y equals -5x. And then what was the other part? Plus 12. Okay. So for this one, because we have a coefficient on the y, we don't know our slope yet. So real simple. Just divide everything on both sides by 4. That will cancel there. Now we have y equals -5x plus 12/4. All right, and then if we want to simplify this to make it really clear what the slope is, that's just going to be the same thing as -5x/4 plus 12/4, which is 3. All right, and then that will give us a slope of -5/4 x. All right, so there's our slope. There's our slope. You can see that these are flipped, and one of them is negative, which means they are opposite reciprocals. Therefore, these are perpendicular lines. Okay, and then the next thing I want you to do after seeing that one is go ahead and try out Got It problem. We're going to do 2A. All right, so do that, and then we will move on again. All right, so once you're done with that, problem 2A, we'll go ahead and look really quickly at problem 3, which says writing an equation of a perpendicular line. So which equation represents the line that passes through the point 2, 4 and is perpendicular to the graph of y equals 1/3 x minus 1? They do give you multiple choice here. We're not going to worry about that, though. So we're going to look at the point 2, 4. And then the line is y equals 1/3 x minus 1. Just like last time, all we need is our slope and our point. And we can write in point slope form. Okay, so we're going to go ahead and give that a try. So we're going to have y minus y1 our y1 is 4, so y minus 4 equals m, which is the opposite reciprocal of 1/3. So then 1/3 has to become negative 3 over 1, all right, which is equal to negative 3. So our slope is now negative 3, and then times x minus x1, which is 2. There's our equation, point slope form, and then of course we've got to get it to slope intercept form in order to find which of those 4 options this one is. All right, so we've got y minus 4 equals distributive property, so we have negative 3x plus 6. All right, don't forget those 2 negatives become positive, and then add 4 to both sides, so we get y equals negative 3x plus 10. All right, that's your equation, which would be option D up here. Okay, so yeah, that's really it for problem 3. Go ahead and try got it problem 3 on your own just to make sure you've mastered this a little bit. All right, and then the last problem here, this is page, what is this, 333. So we've got a real world problem, which is always nice. So this one's about architecture. So if you want to do architecture or you're interested in it, here you go. So an architect uses software to design wow, I forgot how to read. An architect uses software to design the ceiling of a room. There we go, did it. The architect needs to enter an equation that represents a new beam. The new beam will be perpendicular to the existing beam, which is represented by the red line. The new beam will pass through the corner represented by the blue point. What is an equation that represents the new beam? All right, so the first thing we need to do is find out what our slope of the existing beam is. All right, I see that it goes through the points 0, 8, and then it also goes to the point 12, 0. All right, these are different than the points they use here, but it should work out all the same. All right, so our slope, if we use our slope formula, is y2 minus y1. I'm going to do 8 minus 0 over x2 minus x1, which would be 0 minus 12. All right, that's going to give us 8 over negative 12, which is the same thing. If we simplify as negative 2/3, there's our slope. Okay. All right. So then it asks us, the new beam will pass through the corner represented by the blue point. That's the point 12, 10. Okay, so we've got to go through the point 12, 10. And then it needs to be perpendicular to the existing beam, which is negative 2/3 for our slope. So our new slope needs to be the opposite reciprocal. All right, so we're going to flip it. So instead of 2 over 3, we're going to have 3 over 2. And instead of negative, it's going to be positive. Okay, so there's our new slope. Now all we got to do is write our equation. So we have y minus y1, which is 10, equals m, which is 3/2, times x minus x1, which is 12. All right, and then again we simplify, get it down to slope intercept form. So we have 3/2 x, and then 3/2 times negative 12, I believe, would be negative 18. Okay, then we add 8 to both sides, or sorry, add 10 to both sides right here. And that's going to give us y equals 3/2 x minus 8. And that is it for that problem, all right? So that would be our equation for this problem. All right. Once you've got that down, go ahead and do got it problem 4. All right. And then after that, you are done for this video lesson. So I will see you in class.